Inside this pretty ordinary-looking shell is one of nature's most extraordinary feats. It's a complete, self-contained recipe for life. So today, we're going to break down that recipe, step by step, and really get into the precise science it takes to bring that life into the world. I mean, just look at it. A fertile egg is basically a perfect, self-contained life support system. All that potential is just locked away inside. So the big question is, what's the key? How do you turn this simple blueprint into a living, breathing chick? Well, that's where artificial incubation comes in. But don't think of it as some kind of magic. Think of it more like a biological recipe, a really complex one. And just like any fancy recipe, if you get even one tiny ingredient wrong, the whole thing can fall apart.
All right, and like any great recipe, your success really begins with the quality of your ingredients. In this case, that means you have to start with a healthy, viable, and fertile egg.
So how can you even spot the difference? Well, it's subtle, but it's definitely there. If you look closely at the yolk surface, a fertile egg has this distinct little germ cell that looks like a 3 to 4 millimeter white ring. An infertile egg, it just has a smaller, solid white speck. That little ring, that's the very first sign of potential. Now here's something you might not realize. The process doesn't actually begin in the incubator. Nope. How you store the egg beforehand is just as crucial. It's got to be kept cool, but not too cold, turned daily to keep the embryo from sticking, and you really want to use it within about 10 days to get the best chance of success. Okay, so once we've got our quality ingredients all sorted out, it's time to get to the method. Let's dive into the 4 critical instructions in this recipe for life. These right here are the non-negotiables: temperature, humidity, ventilation, and turning. Every single one has to be perfectly balanced with the others. It's that delicate dance that transforms the simple stuff inside an egg into a complex, living embryo. First up is the most critical factor of all: temperature. For a chicken egg, the absolute magic number is 37.6 degrees Celsius. Not 36, not 38. The precision here has to be perfect. And believe me, the stakes for getting this right are incredibly high. A shift of just 1 degree can cause huge problems. If it's too hot, you get weak chicks with all sorts of developmental issues. Too cold, and the hatch gets delayed, which leads to equally serious complications. All right, next on our list is humidity. Now, this one's a little tricky because it's not just one setting. It's a 2-stage process. You need a nice, stable, moderate humidity for the first 18 days, but then you have to make a crucial adjustment for the final 3 days to actually help the chick hatch. And getting this balance rate is literally a matter of life and death. If there's too much humidity, the chick can grow too large and actually drown inside the shell. But if there's too little, it can get glued to the membrane, completely unable to break free. Finally, the embryo needs to breathe and it needs to move. Proper ventilation makes sure there's a steady supply of oxygen while getting rid of carbon dioxide. And turning the eggs several times a day is absolutely essential to stop that delicate little embryo from sticking to the inside of the shell. Oh, and here's a fun fact: an uneven number of terms is actually best. So here's a quick cheat sheet for a chicken egg. You can see it right there. Notice that slight drop in temperature and the really big jump in humidity for those last 3 days. That change is the signal for the final stage, and it's what makes a successful hatch possible. So with all these super specific rules, how do we even know if our recipe is working? I mean, you can't just crack it open to check, right? Well, amazingly, we can actually peek inside the egg without ever breaking the shell. This super simple but totally brilliant technique is called candling. All you do is shine a bright light through the shell in a dark room, and it gives you this fascinating window into the world of the developing embryo. It's pretty incredible. After about a week, a healthy, viable embryo will show up as a dark spot with this amazing spider web of blood vessels growing all around it. If the egg is just clear, well, it's infertile. And if you see a distinct blood ring, that means the embryo started to develop but died early on. This lets you remove the eggs that aren't going to make it. Okay, here's another key progress check, and this one is all about weight. The eggshell is actually porous, which lets moisture escape. So by hatching day, a healthy, developing egg should lose about 13% of its starting weight. This weight loss is absolutely essential for creating the little air cell the chick will use to take its very first breath. But even with the best recipe in the world, things can go wrong. The amazing part, though, is that the results of the hatch, even the failures, can tell you exactly what part of the recipe you need to adjust for next time. You can basically work backward from the results. Think of it like a little forensic investigation. If the chicks hatch early, but they've got defects like crooked toes, the temperature was almost certainly too high, speeding everything up in a bad way. If they hatch late and they're large and sluggish, the incubator was probably too cold, slowing everything down. And humidity problems? They have their own very distinct signs. If a chick is stuck to the shell, that's a classic sign of low humidity. The membrane just dried out and glued them in. On the other hand, if a fully formed chick doesn't even start to break out of the shell, it often means the humidity was too high, which stopped the air sac from forming properly for that first critical breath. So, when you look at all these different variables together, you start to realize that successfully hatching an egg is a true testament to precision. It's this incredibly delicate dance of biology and physics. I mean, just look at this quote from our source material. This really drives the point home. The difference between optimal growth and a higher death rate is a shift of just 0.6% in carbon dioxide. That is how razor thin the margin for error really is. So what this all comes down to is that creating new life, even with all our technology, isn't about overpowering nature. It's about respecting it and meticulously recreating its formula, a delicate balance where every single variable matters. It really makes you wonder, doesn't it? If this level of complexity is happening inside a common egg, what other incredible, delicate formulas for life are at work all around us, just waiting for us to understand them? Thanks for joining this explainer.